for 3, and then for some large cases and very difficult cases, we did manual modeling, and then we did a scoring. For scoring, we borrowed the ideas of the actually we use a borrow IF jury, which is a Venkrobus Labs scoring function, but we added some more terms here, and then finally, class as we do always classically, we meet every day at 3 p.m., 5 p.m., and then discuss the individual models. So for AlphaFold 2, we did two things. One is about the multiple sequence alignment. We don't have we're working on several different things using AlphaFold 2 and 2, but we don't have our own competing methods for general structure prediction methods. But what we can do is to do a little bit about multiple sequence alignment or scoring, and this is we added the sequence database from Logan. This comes from the Capri meeting I attended in Grenoble in February. After the Grenoble meeting, I met Ryan Chicky. Actually, he is my good friend of mine and I visited him in Paris, and then we talked about it. And then, since he's working on meta genome, I asked him if there's anything you can help me. So then he said, actually, we are working on this Logan, and maybe you can try that. So that's what we did. So Logan has a huge amount of data. It takes many hours to download it. At that time, the paper is available on bioRxiv, but at that time, the GitHub is already ready in spring. So we downloaded it. Against this database, we only did the jackhammer search one iteration and added that MSA on top of the regular MSA in AlphaFold 2. Okay, so then here is our pipeline. So we have AlphaFold 2 with AlphaFold 2 multimer for 3 different parameters. Those are 3 parameter sets. And then I have 2 databases, 2 MSAs, the regular MSAs from AlphaFold, and also adding the Logan. So in total, we have 3 by 2, 6 combination of the MSAs and then parameter set. And for each of them, we generate 25 models. So then that gives that 150 AlphaFold 2 models. And then, for many cases, we also run AlphaFold 3, so that gets additional 5. And then we also did, as John Lim mentioned, we also did fold-seek MSA search also, not for all of the cases. When you lack MSA, we did a fold-seek search. And then that add additional models. And then we went to the ranking. Now for ranking, this also comes from my experience in the Capri meeting in Grenoble. I was so impressed in Grenoble meeting that Venkrobus group did very well with the scoring. We are at that time at the second in one of the ranking, but the Venkrobus group really did well. Always did better than us, and that was very impressive to me. And then I talked with the student and then learned how it works. So then IF jury is available on their GitHub website. But to add a little bit different, to add some difference, we added 3 scoring functions, GOP, DeFi, and IT Score Pro. IT Score Pro is by Xiaoqin Zhou. On top of those 7 scoring functions already implemented in IF jury. So these scores are coming from Lizard rank sum score. We have been using our rank sum. This is a consensus type of scores. But then the Lizard was only checking the consensus of the ranking. But the borrowed IF jury also considered the structure similarity, and then that we use for ranking. We did the benchmark with the original borrowed IF jury, and then borrowed IF jury plus this component of Lizard scores on the CASP-16 data set. And if we added, there was some slight improvement for a few cases. So that convinced us to just go with this our scoring function with 3 additional scores. So this is the summary of the models, where the models come from. For top one models, most of the models, the majority of the model came from AlphaFold 3. This AlphaFold 2 custom is the AlphaFold 2 with the Logan MSA. And this is AlphaFold default. This is one of the parameters with AlphaFold regular the MSAs. Others means that either we did manual modeling or we selected from the massive fold or something. Then top 5 models, then we have more AlphaFold 2 customs more. So when we selected 5 models in discussion, in like afternoon discussion every day in summer, we selected AlphaFold 3 model at least once because, well, we cannot ignore AlphaFold 3 because on the paper it has some gain of over AlphaFold 2. But we also make sure that we select one of this AlphaFold 2 custom with Logan, but because there's some originality we have there. So if our model is winning, maybe this should be the one which should model do better than other methods. And then for the rest, for the rest, based on we also pay attention to make sure that the 5 models are very different to each other to bet different places. So this slide is we got from the organizer. This is a performance difference between our model against the other top models, excluding us. So actually, those are the two targets we did clearly better, and those are two models we are tied with some other groups. So for the rest of them, we are not too far off, but we are not the winning all or many. We are not the top modeler for many targets, but there are some significant failed targets. So we highlight these winning targets and then failed targets. Okay, so this is the one which we won a lot. So So for this model. Okay, so this is A3B6 complex, and then as I mentioned, we ran the AlphaFold 2 with Logan, and then AlphaFold 3, and then we did the jury ranking. Then those are the models. So and this one with AlphaFold 2 with Logan multiple sequence alignment made this beta helix here, which was the correct one. Fortunately picked up by the scoring function. So this is so this is PDB, the correct structure, and then these are the 5 models, and among these 5, the one which have this beta barrel has a RMSD overall 6.17. Only this one had this beta barrel structures. Those are the bottom part, A3 part, was almost same for all of the models. But this the B6 part was a bit different. And then, the jury methods was able to pick this up. Now, okay, so organizers also asked us about this target. So this target was H1265. This is a filament target. So when for phase 0, we did not know the stoichiometry, and I think we submitted A2, B2 to targets. Then at A1, phase 1 time, our team did the Google search again with now the keyword of filament and also the many several keywords, including that also if you probably everyone find the template of this TIR, which is a 5UZB. This can be found by the I think we find it by HHPred or HHPred search, and then we also find that the author's name, and then we did the search, and then we find this one page abstract from IUCR and 2023. Sorry, I want to go back to Okay, yes, this one. Right. So then we found this abstract. This is abstract in the X-ray crystallography conference in Melbourne, and this one page abstract had this one figure. So then we thought, okay, we can try to do manual modeling. This abstract says this filament has three complexes, three states, six-stranded and nine-stranded complexes, and then we had this template. And yeah, for this chain B, 6-mer, and then 3-mer A chain A is also very similar, has a sequence, the very high sequence identity to this part. So we also did the homology modeling, and then this is a correct answer, and then we look at actually Yuki Kawaya sitting over there was looking at the figure, and then try to make this manual modeling, and which resulted in this shape. RMSD is large, and then I heard that the interface are not correct, but overall shape looks similar. So these are the nine chain complex, and then since that abstract also mentioned the 6-chain complex, so we also made the 6-chain complex using basically modeler. And that was about this target. And okay, so this is one which we failed significantly. This is the antibody target. Our first model picked up the wrong interaction between the antigen and the antibody and antigen. So this antibody should bind here, this part, but the score selected this part. So yeah, this consensus score is not specifically working for antibody antigen cases. And then although there was a structure in the pool, we did not pick it up. Release, please. Yeah, and then I think it's almost done. So yeah, what went well? So we made the enhanced MSA with really large MSA, and then scoring worked for many cases. Well, it didn't work for antigen and the antibody cases specifically. That was a significant downside of the jury methods. But that is a new thing we added. And then yeah, group discussion. As we still do the group discussion every day in summer, and then that worked. And then actually, we also had the 3 undergrad students in my lab. And then in the past, undergrad students could not do much, could not contribute too much to the Capri. But now we have AlphaFold 2 and AlphaFold 3, and everyone gets a very nice structure if undergrad student can push the button. So each target is assigned to each members of the lab, depending on the difficulty of the difficulty level. For very difficult one, we did manual modeling with experienced researchers. For easy ones, undergrad student did it. Yeah, what went wrong was antibody docking. That was Kozakov and Vajdaslav did very well. And then yeah, downloaded it. Against this database, we only did the jackhammer search one iteration and added that MSA on top of the regular MSA in AlphaFold 2.